Alright, so here's one of our graphing problems similar to the ones that we made our screencasts of this year. So, let's see, there it is. Okay, so the parent function is not going to have the -3 and it's not going to have the 1 attached to it. So the parent function is going to be y equals 2/3 the square root of x. Okay, so that's the parent function. Then I'm going to use a table of values to graph that. And I think it said use 0, 1, 4, and 9, 0, 1, and 9. Okay, I could also use 4. So I'll just do 0, 1, 4, 9. So I put my values in there into the function of the parent function, and I get 2/3. Here I'm going to get 4/3, and here I'm going to get 6. So my points are going to be 0, 0, 1, 2/3, 4, 4/3, and 9. Let's see, 3. I'm sorry, it's not 6. 3 times 2/3, it's 2. Okay, so 9, 2 is going to be out here. So there. That's my function. And the reason the function does not exist in quadrants 2 or 3 is that you can't take the square root of a negative number and result and get a real answer. Okay, so what have I done so far? I've graphed it. I've graphed the parent function using identify the direction of magnitude of the shift. Okay, so really -3 there is the same thing as +3. So the shift is going to be, let's see, 1 to the left and 3 up. So I'm going to graph the shifted function now. I'm going to go 1 to the left and 1, 2, 3. 1 to the left and 1, 2, 3. 1 to the left and 1, 2, 3. And 1 to the left and 1, 2, 3. So that's my shifted function. And now I need the domain and range. So the domain is going to be all real numbers greater than or equal to -1. And the range is going to be all real numbers greater than or equal to 3. So if you look at it, the graph never exists anywhere where x is less than -1. And it also never, the parent function or the shifted function never exists anywhere below y equals 3. So that's why the domain and range are that. And let's see what the next one is. So that was a square root function. So cube root function, essentially you do the same thing. The parent function here is going to be y equals cube root of, let's see, well, this one is a little trickier. Okay, so maybe I shouldn't have put this on here, but what I'm going to do is, um, let me pause the video and decide what I'm going to do. Okay, so I wouldn't expect you to know this, but y equals the cube root of -8 minus 24. You can factor out a -8, and you get x, let's see, +3. Well, the cube root of -8 is -2. So really my function is this one. The problem is really cube root of x plus 2 and then plus 1. Okay, so that means my parent function is going to be y equals -2 cube root of x. So if I do my table of values with -8, let's see, -1, 0, 1, and 8, I get the cube root of, that's -2, I get 4. The cube root of -1 is 1, I get 2. 0, let's see, -2, and -4. Okay, so let me graph those points. So I get -8, +1, 2, 3, 4, -1, +2, 0, 0, 1, -2, and 8, -4. So really my function, that's the parent function. Okay, so what's the shift here? Well, it's going to be 2 to the left, because +2 means 2 to the left, and 1 up. So I would do everything 2 to the left and 1 up, 2 to the left and 1 up, 2 to the left and 1 up, 2 to the left, 1 up, 2 to the left, 1 up. So it looks kind of funky, but that's the shifted function. Nice thing about these functions is domain, always all real numbers. Range, also always all real numbers. And that's it. Okay, solve the compound inequality. All right, I'm going to subtract 2 from all three sides. This is an and or in between inequality. I get 0 greater than -7a greater than equal to -63. So I'm going to divide everything by -7. And I end up with 0 greater than a greater than equal to 9. Let's see. Am I doing this right? Yes, I am. No, I'm not. So what did I do wrong here? Greater than or equal to -63. Oh yeah, I forgot to change the direction of the inequality signs when I divide by a negative number. Yay. Okay, remember that. You have to change the directions of the side when you divide by a negative number. So I end up with, let me just write, okay, I'll write that one the way it originally was. Okay, and now I end up with that. Okay, so that's your solution. Okay, here's an absolute value equation. So I get the absolute value expression all by itself. So I'm going to divide by -6. Okay, so now is the key step. I have a less than inequality, absolute value inequality. So what do I do? In the case of the less than, I end up rewriting it this way. Okay, you take that 2, put it down there, put a minus sign in front of it, get rid of the absolute value symbols. And I get 0 less than or equal to 10r less than or equal to 4. And now I divide everything by 10. Oh, I guess it's raining. And what does that give me? It gives me, I'm in between 0 so equal to r less than or equal to 2/5. And that would be that one. Okay, here's an absolute value, an equation has an equal sign. So I need to get the expression by itself that has the absolute value symbols. And remember, you never distribute into an absolute value expression. So I would never multiply 4 times negative 10a or times negative 7. So you get negative 10a minus 7 equals 17. Add 7. Oh, I'm sorry, I'm not paying attention. So I'm right here, and now here's the key step. You have to know this. Okay, so I rewrite it without the absolute value symbols, and negative 10a minus 7 equals 17. So here I'm going to add 7 to both sides, get negative 10a equals negative 10, divide by negative 10, and I get a equals 1. Okay, here I do negative 10a, I'm going to add 7 to both sides, divide by negative 10, and I get a equals, let's see, negative 12 fifths. So I get two solutions. A equals 1, a equals negative 12 fifths. Okay, I think I'm going to pause the video and or end this screencast and then start a new one in a few for the word problems.